Today, we're talking about how traditional software engineering teams struggle to build AI. One common problem that I'm hearing from business leaders is they have an idea for an AI project, they hand it off to a team of traditional software engineers, but then a few weeks or months later, they still have stalled progress. It seems rational. AI is just code, right? The truth is, that's not quite true. AI engineering and software engineering do have some areas of overlap, but AI engineering is very different in some ways from traditional software engineering. Hi, my name is Joshua Ebner. I've been in the AI and data science industry for over 20 years, including at companies like Apple. And the failure pattern that I just described is actually fairly common. So in this video, I'm going to explain why traditional software engineers sometimes struggle with AI projects. I'll explain a little bit more about what AI engineering is and how it's different. And then I'll explain what you as a business leader can do in order to have more successful AI projects that drive serious results. So let's just start off with the frustration and the pain that I'm hearing from business leaders right now. Over and over again recently, I've been hearing from business leaders, all the way from CEOs, but also from other senior leaders, that their frustrated software engineers are struggling a little bit with AI. They have an idea for an AI project. They give that idea to a software engineering team, but weeks, maybe even months later, the pilot hasn't fully launched. It's brittle. It doesn't quite work in production, or it works for a little bit and then it starts failing, and so on. Now, one of the first things that I want to say is this is very common right now. I also want to say that many software engineers are great at software development. And even if you pass an AI engineering project to a great software engineer, they might still struggle. So it's often not a problem with the software engineer. It's actually a deeper problem that relates to a fundamental skill mismatch. Let me explain. In most cases, traditional software engineering teams are not equipped to lead AI delivery. This is a core point that I need to get across. The skill set is different. Traditional software engineering deals, for the most part, with deterministic systems. You have an input or a set of possible inputs, and then there is a sort of if then logic that evaluates those inputs. If this, then that, and so on. And if there's an error, it can throw an error. It's a little bit more complicated, but for the most part, these systems are deterministic. But many modern AI systems, especially if they're built with a large language model, but this is also true of some other types of AI, they are not perfectly deterministic. They are, in many cases, probabilistic. Again, it's a little bit more complicated and there is some nuance, but at a high level, it's roughly true. Most modern AI just works differently than traditional software, and it has a variety of different failure modes. The inputs to modern AI systems are, in many cases, more diverse. And if you're using something like a large language model or a similar system, the potential outputs are way more diverse. We would say that the outputs are much more high variance, and it requires a different set of skills. Furthermore, modern AI engineering, if you're building, let's say, a chatbot, certainly if you're building an AI agent, or if you're building something that's more like traditional AI, a predictive system, a recommendation system, and so on, these require very different skills. I'm talking about things like complex data engineering, data labeling, and data acquisition, training systems. So for example, if you build a predictive system or you need to kind of tune up a AI agent, you often need a data set and you need to train that AI system to behave in a particular way. This comes from traditional machine learning, and it's actually a machine learning skill set to do this. Then you have AI deployment, which is related to traditional software deployment, but it's also a little bit different because of the nature of the outputs, the nature of things like what we would call model drift, and so on. Deployment for AI systems can look very different. So it requires a different set of skills. Again, I want to emphasize there is some overlap. A lot of AI engineering involves programming and code, but it requires additional and different skills that the vast majority of software engineers do not have. So even if you have great software engineers, for the most part, they're going to struggle with serious AI projects. By the way, if you want to know if your company is really ready to use AI, Click the link in the description below. Go take my AI readiness assessment. It's 15 questions. It'll take you less than 3 minutes, and it will score you on 3 major areas that will tell you your AI readiness. Click on the link in the description and take the AI readiness assessment right now. Now, there is a solution to this, but in order for me to explain it fully, I actually need to talk about the real goal that business leaders have. When a business leader goes to a team and says, hey, build me an AI system, they don't actually want the system itself. They just want the business result. The system is a tool or a method of getting to the business result. So typically that's things like increased revenue, decreased costs, higher profit, or increases in some key business metric like customer satisfaction, customer retention, lower cycle times, lower defects, and so on. What I'm getting at is that in any AI project or any technology project at all, there's actually a business outcome that you're trying to drive. And that's important because keeping that in mind is part of how you put together a team that builds great AI solutions. So, with all of that said, how do you fix this? Number one, if you want great AI systems, you're going to need some serious AI engineering talent. As I suggested previously, AI engineering is different from software engineering. So either you need to hire a proper AI engineer that has the full suite of AI engineering skills, that includes programming, that also includes things like traditional machine learning skill, a little bit of data engineering, model evaluation and testing, AI deployment, and so on. There is a role for a traditional software engineer to work maybe in concert with an AI engineer, but AI engineering is separate. So you either need to get people that have that skill set, or you need to take a traditional software engineer and get them some training and upskill them. So that is an option. You can upskill a traditional software engineer. But in order to build a team that actually delivers strong AI solutions, you actually need a couple of other things. So you need to involve your business people. The business people help define the problem. In any AI project, as I was sort of suggesting a minute ago, it starts with the definition of the business problem. What are you trying to do? This is really important. Always start with the business problem that you're trying to solve, then work backwards. So you need business people in the room to help with problem definition. This could also involve some subject matter experts that understand the specific problem that you're trying to solve. Maybe at a business level, you're trying to solve for higher revenue, but 1 or 2 levels down, it's actually maybe a customer retention problem. And you might have an expert in your customer retention, a person that understands the churn problem best. You want that person in the room because they will help evaluate some of the solutions. Then you're also going to involve your AI engineers, maybe some traditional software engineers as well, and some IT people for deployment and scaling. You get those people into a room, start with the business problem, brainstorm potential solutions. Then the subject matter expert and AI engineering team will usually go away and build a couple of prototypes. And then after a few weeks of prototyping, they will come back with a couple of potential solutions, and everyone will be able to take a look at the pros and cons. Which one is going to be more or less costly to build, more or less costly to run, which solutions look like they're more or less likely to drive the key metrics that you're interested in. Everyone can weigh all of the options and pick the best one. And if there isn't a great solution, sometimes you just decide to kill the project altogether. But it's actually a process that involves AI engineers and business people and subject matter experts working together to find a solution to the business problem. So that's sort of a high level overview of how you can solve this issue with a mixture of AI engineering talent and software engineers and other people inside of business. But I want you to understand that this problem, where software engineers sometimes struggle with AI, is very common, but it is solvable. And the businesses that follow the pattern that I just described with a somewhat diverse team of people working on these AI projects, those are the ones that are very commonly getting strong results. But if you want even better results, you have to go beyond just getting the right people in the room. You need to develop a strategy. And that's why I recommend that you watch this next video. In this next video, I'm going to explain how to build out a more comprehensive AI strategy, how to think about the types of projects to invest in, how to pick your use cases, how to think about your data assets, and ultimately how to build your business into a system that compounds competitive advantage over time. You can check it out here. How to build a great AI strategy.